All right. So starting with the first chapter, as I had mentioned, I have divided this first chapter into two halves. The first half is basically regarding the atomic structure, interatomic bonding, and primarily we'll initially look into the structure property concept that I had uh, mentioned in the introductory section. And the second half is basically dealing with the classification of metals. So starting with the first half essentially, when we move on towards atomic structure and interatomic bonding, you would be familiar with this as uh, you have learned the concepts and the knowledge. You've gained the knowledge in your high school physics and chemistry. So moving on towards the overview of this uh, lecture. We'll start with the introduction to material science and engineering, probably what is the role of material scientist, what is the role of a materials engineer or mechanical engineer having the knowledge of material science, uh, how we classify engineering materials into different categories, what are the broad categories in which we can classify our materials, and then we'll look into the uh, traditional Bohr's atomic model, how the electrons are classified in a Bohr's atomic model. Then what is the more revised quantum model? How do we define the quantum numbers? How is electronic configurations of different elements uh, being configured? And we look into the periodic table, the general structure of the periodic table, how the metals are different from non-metals, what is the trend that is being followed across the table and down the table. So we'll try to classify different groups, and then we'll look into bonding forces and energies. What happens when two atoms come together to make a bond? How are the forces interacting with each other? What is the uh, energy curve? What is the stable energy position? We'll try to understand that. Then we'll move on towards the primary interatomic bonds that are ionic bonding, covalent different classification of materials would essentially have different categories of these bondings, and we'll also look into the secondary bonding or the van der Waals bonding, which would be which again you would be familiar with. And the last part of this chapter 1 would cover the classification of metals. How do we classify metals into different groups, whether it is the ferrous class or the non-ferrous class? What are the generic applications of these classification of metals, different classifications of metals? So you have an overall understanding that if my application is regarding um, an automotive engine, what is the category of material I'd be looking into. So how to this classification would give you the basic criteria to decide how to select the materials for your corresponding applications. So this is the overview of the chapter that we'll be looking into. Then comes the introduction. So I'll start with the basic definition that derives material science. Again, investigating the structure property relationship. We'll deal with structure differently, and we'll try to understand what is meant by property differently, and try to make up the meaning of structure and property. So uh, I have Nomer, I have already asked, kindly stop sending the messages in the chat section regarding the attendance. I'll mark your attendance by calling upon your names. So you don't need to type in your uh, names and registration number for the attendants. Moving on towards the structure property relationship, materials engineering is on the basis of structure property correlations and designing the structure of a material to produce a predetermined set of properties. So you basically play with the structure of a material, try to get different structures to get the desired set of properties. Obviously, you need to have an understanding of it, which is preferentially more important because you are probably not in the phase of designing the structure. But understanding which structure relates to which properties is an important part. So the scope of a material scientist, the traditional scope of a material scientist is to develop or synthesize new materials, which normally today chemists or physicists or material scientists are generally working in this domain. But this domain is nowadays not limited to material scientists only. Engineers also are working in a domain that overlaps with this domain. But the prime function of a material engineer or a mechanical engineer is to create new products or systems. You have to create a new products using existing materials. So you need to know the structure of existing materials and thus the properties of these materials in order to create new products. Or another aspect of an engineer would be to develop techniques for processing of materials. If you are um, if you are working in a steel mill and you are overlooking the rolling process or an extrusion process, essentially you should be familiar with the structure of a material and how it is related to the processing conditions in order to optimize or develop a synthesis route for yourself or manufacturing route for yourself. This understanding of the structure of material is essential. So what is essentially meant by the structure of a material? We classify the structure of a material as related to the arrangement of internal components. When I say arrangement of internal components, I mean to say that there could be a subatomic structure. When I say subatomic structure, it basically means it involves electrons within the individual atoms and their interaction with the nuclei. This is the level of structure that probably you'll not be that much interested in because this structure basically determines the uh, electrical and thermal properties of the materials. Probably the mechanical engineers, they are not much focused upon this structure of a material. But a structure that is important for you is the structure at an atomic level, that how the atoms are organized together with regards to one another, or how the molecules are situated in a 3D space with regards to one another. This portion of structure is basically the portion that deals with the terminology known as crystal structure. So the atomic structure or atomic level structure is basically uh, the structure that determines your crystal structure. And how do you identify the crystal structure? The technique that we'll be looking into would be the X-ray diffraction. That would help us identify the crystal structure of a material or how the atoms are arranged within the material. Moving on to the other part of the structure is where large group of atoms that normally agglomerate together, they form the microscopic structure of a material. This microscopic structure is normally characterized or analyzed using a microscope. So this large group of atoms coming together, this is basically the microstructure of your material. And in order to identify this, you normally work with the help of a microscope. So these two structures would be the one that will be trying to understand both in terms of how they look like, what are the essential features, and how to characterize these structures, and essentially how these structures affect the mechanical properties. And finally, the structure elements that could be viewed from the naked eye, they are known as macroscopic features of a structure. These macroscopic features, they are normally used in evaluating the failure mechanism of a material. How did the material fail? You not preliminary guess using the macroscopic structural analysis. So these are the categories of your structure. Now, the important thing is that a property, we have looked into structure, we'll now look into what is meant by a property. A property is a material trait or a material characteristic in terms of its response or behavior in terms of magnitude and both kind to a specific imposed stimulus. In in order to more clarify it, we have divided properties into 6 basic categories. Mechanical, how do a material react to an external force? To a specific imposed stimulus, means that could be stretching the material in one direction, applying tensile force on a material. How do material react to this force in terms of kind and magnitude would define the property of a material. So there are mechanical properties that are determined with regards to elastic modulus, which is also known as the stiffness of the material, the strength of the material, which is the tensile strain, the yield strength, or the ultimate tensile strength, the toughness of a material, which determines the impact resistance of a material. So these, the reaction of a material in terms of magnitude and kind with regards to an external mechanical force is basically categorized as mechanical properties. Then there are electrical properties that determine the electrical conductivity of a material or dielectric constant. There are thermal properties, how good a material is in terms of thermal conductivity or in terms of in storing the heat. Uh, is it a good thermal insulator or not? Magnetic properties, what is the response of a material in an external magnetic field? Then there are optical properties. How is the material's behavior to exposure to light? Its refraction index is how? Is it a reflective material? Uh, and the last category of material property is essentially the deteriorative characteristics. That means the chemical reactivity of a material, or what is the behavior of a material in terms of its degradation in a specific environment, or what is the corrosion resistance of a material in a specific environment. So now, now you are familiar with the properties, which properties we are looking into. Primarily, you'll be looking into the mechanical properties and the deteriorative properties. And these properties are based on the structure of the material. So we'll try to understand what is meant by the structure of a material. We have already classified the structure into 4 categories. The most important categories are the crystal structure and the microstructure. Other than these 2 concepts of structure-property relationship, the 2 important concepts are processing and performance. If you see the relationship of these 4 components, structure, properties, processing, and performance, essentially the structure of a material is dependent upon how it is processed. Your job as a mechanical engineering most probably would be in processing the material. The one of the main jobs that you could have. So you need to know how your processing would affect the structure of a material. In order to know that, you need to have an understanding of what is meant by the structure of a material. So to better process it. The second concept is the performance. Once you have the structure, you will have some definite properties with regards to that structure. And these properties would lead you towards your ultimate goal, that is the performance of your material or your design. So essentially, processing is an important part for you. This processing would help you get the desired structure. So you need to have an understanding of what is meant by the structure in material science. Once you know the structure, you can predict the properties of your material. And once the properties are close to your predicted properties, you would have the desired performance. To cut it short, let's have an example of a same material which is known as alumina. The same material, alumina, which is composed of uh, two atoms of aluminum and three atoms of oxygen, uh, the same material could be processed differently in order to have different optical properties. That means you can have processed them differently to have different structure. As a result of different structure, you will have different optical properties. So processing differently would give you different structure, and different structure would give you different optical properties. Let's see the three materials. The three materials, all the three materials are basically alumina. They are processed differently. One is processed in a way that it is having single crystal as its structure and it appears transparent. So you processed differently to get different structure and in order to have different optical property. Similarly, the other is processed differently to have different structure, which is polycrystalline structure, and in order to have different property, which is translucent. So something is visible, portion of the paper underneath is visible. Then you have a polycrystalline material which is processed differently such that it has certain number of pores held within it so that the final performance or final property of the material is different. It is opaque. Now, once you have these properties in front of you, you can essentially choose the right property to get the best performance. Obviously, you cannot use the opaque, this one, to to prepare the uh, glass eyeglass for your eyeglasses, obviously. So once you have an understanding of processing, you'll have an understanding of structure. You can mold your processing route to get the desired structure and in turn the desired properties to get the optimum performance out of your material. So I'll stop over here.